two topics, power series and Fourier series. So let's practice power series first. The first question, solve ODE by power series method. All right, let's look at this question. So the question, I'm going to give you right-hand side, two terms, okay? No x squared term, to save you some computation time. So, but I just changed these three numbers, okay? Yeah. So I will, what I do, changing those three numbers. Yeah. The first one, let me just walk you through. Second one, you practice. Okay. Yeah. All right. First one, and at the same time, I may give you some suggestions how to save time. Yeah. So basically, we just write the necessary formula steps. So we do not need to write extra things. Okay. Yeah. All right. Even we can save words. Okay. Some words we do not need to write. Okay. You just write formula. I know what you mean. Okay. All right. So then 3 times. So for y double prime, because we write this double prime many times, right? Like that. So in the final, you can write this formula directly. You don't need to write intermediate steps, right? Like first derivative, you write once. Then second derivative, you spend more time, right? If you feel comfortable, write this formula out directly. Then you just write it out. You can save some time. Yeah. So that's one way to, yeah. So here I skip this step. Yeah. Remember, so when we do double prime, we have an intermediate step like that. So here, what I mean, we can skip that. Yeah. Although we know from this one we can get that one. Yeah. But if you feel comfortable on this, final one, you just write the last one. Yeah. So that's the how to save some time. Then, because two terms, right-hand side 2 terms, so we only need to calculate the first 2, 0 and 1. Okay? Yeah. When m equals 0, from y double prime, that's 2a2. Okay. You plug in 0, 2a2. Yeah. So then here, 3y, so 3a0 equals 2. Okay? Equals the first right-hand side, the first term, 2. All right. So then you find a2 expression in terms of a0. Remember, we only need to find one particular solution. We just need to write the simplest particular solution. We can, take a0 equal to 0. So then we just use a2 equals 1. Yeah. Because we have freedom to choose a0 value. And for simplicity, we choose 0. So that term is gone. Okay. Similarly, the second one, you plug in m1, so 3 times 2 is 6. 6a3 plus 3a1 equals second term coefficient 3. Yeah. So then you write a3 expression. Similarly, with a1 equals 0, yeah. Yeah. So you get a3 values. All right. So then the general case. The first 2 special cases. Yeah. The general case, when m greater or equal to 2, then we write the general. So general right-hand side 0. Okay? The general, because after the first 2 terms remaining, no terms, 0. So for the general, these 2 expressions, the coefficient expressions adding together equals to 0. Then we write am plus 2 equals negative 3 am. The general, okay? Recursive formula relation. Then we only need to do 2. So after you get general, you only need to calculate the first 2 in the general case. Yeah. All right. The first one, A4, yeah, m equals 2. 2 plus 2, A4 equals 3 over 12. You plug in m equals 2. Yeah, simplification, yeah, because A2 is 1, so negative 1/4, A4. Then A5 use A3, yeah, so you plug in A5, 3, 20, A3, 1/2, yeah, yeah, so you get A3, A5. Yeah. All right, so that's enough. You are ready to write final solution. Okay, the last line. Solution, y equals, yeah, so the first 4 terms, yeah, after, because A0, A1, all 0, so those 2 terms gone, all 0. So you start from A2, coefficient 1, x squared, so then A3 coefficient, yeah, A4, A5 coefficient, then dot, dot, dot. So then you complete. So you complete the first question in the final. Oh, someone try to get in. Yeah. Right, let me get the student in. All right, yeah, I just noticed. Yeah, so think about. So in the final, I will give you similar, simple numbers, okay? So numbers won't be very big, messy, similar, simple numbers. Now you think about, you just do this formulation, this slide. Think about, can you use about 5 minutes to complete? Yeah, so targeting 5 minutes to complete. Yeah, yeah. All right, so here, we have 8 questions, right? 8 questions, 2 parts. Laplace transform 4 questions, non-Laplace transform 4 questions. I think in this way, because non-Laplace relatively easier than Laplace part. So non-Laplace, so we totally have 120 minutes. Non-Laplace, on average, 10 minutes per question. 10 minutes per question, 40 minutes. And Laplace, on average, 20 minutes per question, 80 minutes. 80 minutes plus 40 minutes, 120. Yeah. Okay? Yeah. So manage your time approximately like that. Yeah. Yeah. Approximately like that. All right. Yeah. So next, let's practice. Practice 1. Okay. Similar like this. This one. Try this one. Okay? Yeah. But I work here, yeah. But I wait 2 minutes, then I work here. Okay? Yeah, see if you can, if you can complete, smoothly. Yeah, yeah. So calm down. Yeah. So do not feel, in a hurry. Calm down. Yeah. After you finish, you compare with my calculation. Only write the necessary formulas. Okay? Keep the minimum writing. Just sufficient for your thinking, for your logic. Jenny, it's same? Good. Yeah. All right, I will move to next unit. All right. Next unit, still power series, but different, slightly different method. Frobenius method. Yeah. Yeah. B.2, Frobenius method. That one, this time we have R, little, the equation like that. Okay. Yeah. So equation, yeah. So I will tell you, in the final, I only changed two numbers. Yeah. The structure, the same structure, yeah. But I changed two numbers. Okay. So first is this number. Yeah. Different fraction. Second is this number. X is at the bottom. Keep that 1/3. I changed to a different number. Yeah, still 1 over something, some integer times x. Yeah. All right. Yeah. So this one, yeah. Let me go through. So I do not ask you practice. Yeah. So this one, Frobenius method. When you see that equation, we write a B0. This is B0. Okay? Because we need to solve an equation called initial equation. So we write B0, this coefficient, and C0, that 1/3, that coefficient, C0. After we have B0, C0, we can write that initial equation. Initial equation, this one, you just plug in this form called initial equation. So we plug in After we plug it, we need to find the two roots, two real roots. Yeah. So two real roots, I try to give you good, good one. So here you can see the two solutions. R1, 1/2, R2, 2/3. Yeah. For the case 1 of the Frobenius method, R1, R2, first, I want to make these two roots both non-integers. Second, their difference also non-integer. That's our case 1. Yeah. So this follows that. Okay, non-integer, the difference also non-integer. So that's the case 1. So we only do case 1. Yeah. But later, when we do, use, because I only ask you to find one solution. So you do not need to give me second solution. We use R1, we can get one solution. When we use R2, we can get a second solution. But my question, I only ask you to give me one solution, so you can use the relatively simpler one, R1, simpler. Looks simpler. Yeah. So we take R1. R1 and the Frobenius method targeting Y power series in this format. There is a x to the R1, yeah, because R1 1/2. So here we use x to the R1. Multiply. Inside the parenthesis, it's a power series. That power series. Okay? Before we take derivative, let us multiply through. Yeah. Then we are ready to take derivative. First derivative, second derivative. Yeah. So this one you need to do a little more calculation. Yeah. All right. So first derivative. Okay. Yeah. Power rule, first derivative. Always going to be what? Yeah. So let me answer a question from this student. Yeah. Here. Let me look at the question. B1, B0. Yeah. Always going to be the coefficients of y prime. Yeah. Right. Yeah, so let me answer this question. How to determine B1, B0, C0, right? So first, the ODE should be in this form. So the x times y double prime, okay? If x squared, then it will change. So it should be in this form, x times y double prime. Yeah. So then you look at the y prime coefficient, y prime, its coefficient should be a power series, b of x power series. But here, yeah, look at the original. So here, original form is the b of x times y prime. Then b0 is the constant term of b0 is the constant term of the bx. Okay, constant term. Yeah. Power series. B of x we assume as a it's called analytic function. We know analytic function power series. But in the final, I do not give you complex b of x. I only give you one term, one constant term. That's the b0. Okay? Yeah. Make it simpler. Yeah. Then, so here for the C0, yeah. So then we get to the C0. C0, it has to be, so here, so this one, this place, so we can treat as the C of x, yeah. But here, the C0 corresponds to the term 1 over x term. C0. Okay? Yeah. C0. Why? Yeah, because look at the degree. Yeah. Because think about, so here, let me explain. So why B0, C0 we choose in this way. Y double prime, when you take derivative, you bring down the degree, right? Double prime, you bring down degree by 2. Okay? So degree, total degree of y, you bring down by 2. Then you multiply x, you go back 1. So that means down by 1, right? So this term, the degree from, consider the base y, down by 1. Okay? Degree of y down by 1. Okay? First derivative, degree down by 1. Okay? Degree down by 1, right? Here, because division, degree down by 1, right? When you do division, degree down by 1. So for that reason, these three terms, they have the same degree. Same degree. Same degree, then we can do calculation. We can combine the coefficients. Yeah. So the same degree, when we combine coefficients, that's initial condition, initial equation. Initial equation, all right? So when you determine B0, C0, so you try to fit the pattern, okay? Fit that pattern, yeah. Because I give you, so this we treat like a sort of standard form, although we do not call standard form, but kind of standard form. Yeah. Because this form, simpler for us to see B0, C0, okay? Simpler for us to see B0, C0. Yeah. So I give you this, this form. So you extract B0, C0 out, solving initial equation, get R1, R2, then pick R1, then you take first derivative, second derivative. Yeah. Okay? Yeah. Second derivative. So here, let me do the second derivative. Okay? Yeah. All right. So the next slide, we need to calculate the left-hand side. Yeah. So this question, you need to prepare a little bit, much, harder than the first one. Okay? All right. So the next one, yeah, I copy these three equations to the next slide. So you still have these three equations. Next slide. Okay. All right. Oh, sorry. Yeah, here. Yeah, same question. Continue. Yeah. So I copy these three power series expansion for y, y prime, y double prime. So we try to make these terms. So this one you need to practice. So this one you need at least 10 minutes. Yeah, yeah, a little more than 10 minutes probably. Yeah. All right. Then we start first term, x times y double prime. Yeah, yeah, yeah. Plus 1. Yeah. Double prime. Okay. All right. First one. Second one, you multiply that coefficient. Okay. Relatively easier. Yeah. Negative 1/6. You multiply that coefficient. Okay. Yeah. Second one. The third one, because there are two terms, we like to split. Yeah. We like to do it twice. The first time, we just do the first term multiply that y. Okay. Yeah. The first time we do the first term multiply y. The second time we, 1, we just copy that y power series. All right. So the first time, 1 over 3x multiply y. Yeah. So you adjust, the x part. Yeah. So now here you can see these three rows, their first term, the x part the same. X part the same. Okay. Yeah. And the coefficients adding together should be 0 because coefficients, that's come from the initial equation. Okay? So if you add them up and not 0, that means your initial equation is wrong. Okay? When you solve the initial equation, your solution is wrong. Yeah. So the coefficient adding together, the first column must be 0. Okay, yeah. All right. So then I move to the next slide, but I still copy, three, four rows to the next slide. Yeah. So you still have them in the next slide. Oh, yeah, still, yeah. Oh, yeah. So these 4 rows, yeah. So, yeah. 3 rows I copy from the previous slide. The last one just the y. Yeah, I copy that y and align, make alignment. Align, yeah, because the same term. Then we can add the coefficients of the same column. Coefficient, same column. The coefficient, the first column 0. Yeah, so the coefficient of the first column always 0. Okay, so it's gone. So then we look at adding up the coefficient of the second column. Make it 0. Yeah. Adding up. Make it 0 so we can find A1 equals -6/5 A0. Okay, that's the second column. All right, yeah. Question?
Can you also multiply 3x on both sides of y divided by 3x?
Yeah. You can. You mean multiply 3x both sides?
On the series down below, where's
Here?
over 3x times y. Can you multiply both sides by 3x and change the same solution?
Yes, same solution, but not convenient. Okay? You only do multiplication 3x both sides, right? If you do, alignment is wrong. Okay? Yeah. So you get a y. You get this one. You get this one, but here we need this term. We need this term. Okay? Yeah. So do not multiply. Yeah. Because here we need that term, so you need to make this one, make this expression. Yeah. Do not try to simplify. Yeah, because you look at you can simplify it. Yeah, but sometimes we don't want to do that simplification. Yeah. This is the one simpler one. Yeah. So we still keep it. We have it. But we need this term because that from the equation we need that. Okay? So for that reason, try to understand. Try to understand. Because in your homework, you do similar things, right? Think about your homework. How did you do your homework? The second question. Is it a similar thing? Is it a similar thing? Yeah. So compare it with your homework solution. Right? Julie? It looks puzzling or...
No, sorry, I'm just trying to do the math in my head.
Yeah, sometimes it's hard for me. Yeah, but this one, I try very hard to make it simpler. Yeah. So last night I worked a long time, tried to give you simpler. The first few try very messy. For me, it's hard. So I change. So finally, I need to make the denominator relatively small. So when you do addition, so not too hard. Yeah. Yeah. All right. But you're allowed to use a calculator like Wolfram Alpha. So if you if you need help, so you can use that calculator, online calculator. That online calculator, you can even calculate integral. How good it is. Yeah. When you do Fourier series, you can calculate integral, symbolic integral. Yeah. But I won't give you hard integral. Yeah. All right. Yeah. A1, then A2, a little harder. Yeah, but too much, not too much harder. Okay. A2, yeah. A3. Yeah. I mean, that's, looks, yeah, a little big. So, but we will stop after that. Okay. So we will. So the last step, we are ready to write the final solution. We take A0 out. Yeah. So A1, A2, A3, A4. Yeah. Okay. So, oh, sorry. A0, A1, A2, A3. Yeah. No A4. Yeah. Yeah. No A4. So that's the second question. Second question. Yeah. So in the final, so here, yeah, after you write something, let me summarize a little bit. So when you practice, yeah. So here, because this weekend when you do practice, yeah, I can give you some suggestion. Yeah. Wait. Yeah. All right. So remember, initial. So here, remember that initial equation. This one. Yeah. When you start, you need to solve this one. So when I make question, yeah, remember, I will make R1, R2, two fraction numbers, difference non-integer, but I try to make the two fractions as simple as possible. Because if two fractions relatively complicated, then your computation could be very hard. Yeah. So actually, here I can tell you, I will make R1 1/2. R2 different, okay? R2, different. But I try to make R1 1/2. So when you do preparation, you can only assume R1 1/2. Then that 3 power series, same, right? Yeah. The power series, before you multiply things, y prime, y double prime, the same. Yeah. R1 1/2. Okay? Yeah. R1 1/2. Yeah. But you need to solve that initial equation. Okay? You need to solve that, find two roots, R1, R2. Yeah. If you skip that, you may lose points. Yeah. Initial equation, that at least it takes 1 point. Yeah. So you need to work on that initial equation to get that 1 point. Okay? Yeah. Oh, just a minute. This one question worth 8 points, right? Yeah, 8 points. Yeah. All right. So yeah. So now I can think about, because total 8 points. Yeah. So initial equation. I need to look at how important, how much weight in 8 points. That 1 point I use the 4-point scale. Okay, 4 point. As our homework. Homework 4 point. But 8 points looks like 2 points. 1/4 of total. Yeah. All right. Yeah. So when you do preparation, yeah. So this part, Yeah. All right, so that. But later, this coefficient B0 will be different. Okay? This one, C0, will be different. Okay? All right, so then, you do the remaining. Yeah. All right. Yeah. So we finish power series. And next, Fourier series. Okay. All right. Unit 3, Fourier series method to solve ODE. All right. So the equation format, similar to our homework. So here I won't change left-hand side because if I change slightly, it could be very hard. So I stick with this simpler form. Otherwise, if I only just change slightly, it could be much harder. Yeah. All right. Yeah. So here, you can see comparing our homework question, I only changed cosine to sine. Right? Homework question. Yeah. It looks familiar. Oh, yeah. But I also changed the interval. Our homework question, the interval here, t between negative pi and pi, right? And then here I changed the interval from 0 to 2 pi. That's slightly different. That difference you need to be aware of. Okay? Yeah, you need to be aware of. So our homework question, the range, although the length 2 pi, but for our homework, symmetric about y-axis. This one, not symmetric about y-axis. That's the main difference. All right. Yeah. So now, let's look at how to solve. Yeah. How to solve. Okay. Yeah. And actually, this one, when you take integral, it will be easier than our homework question. Our homework question, integration by parts. So you need to do some work there. Yeah. Here, much simpler than that. Yeah. All right. Here, before you do integration by parts, first we need to consider how to handle this interval. Here, let me draw graph. Draw graph. Okay, all right. 0, pi, 2 pi, negative pi, negative 2 pi. All right. Our function defined on the interval 0 to between 0 and 2 pi sine, right? Sine. But sine, if we do not take absolute value between pi and 2 pi, the graph below the t-axis. Then, when we take absolute value, we flip. Okay? So the graph is like this. So this is the r of t. This is r of t. Okay? All right. So then, when we do 2 pi periodic extension, so that is two pi periodic extension, like that. Okay. All right. Now you tell me how to work. After you look at this graph, when we do Fourier series expansion, our goal, we do Fourier series expansion. When we do that Fourier series expansion, when you see this graph, what's your plan to do the calculation? calculate the Fourier coefficients. What's your plan to calculate the Fourier coefficients? Formula, pick the right formula. Here, my questions. You need to pick the simplest formula. The formula, we have general formula. Yeah, you can do the general formula, but simplest formula, simplest version.
Since it's odd, you just calculate the piece of it correct.
Yeah. But remember, we spend a lot of time consider two cases, even function, odd function. That can make, because even function, odd function, we can cut our computation by half. Here, can you take advantage of that even function, odd function? We can cut our computation by half. That's a lot. Okay? 1/2 of the calculation. That's a lot. Okay? Is this function even function or odd function? Even or odd? Yes. So we pick the even version. Yeah? Same as our homework. It's an even function. Okay? Right, absolute value. Right. Even function, let's take, because it's a periodic, can we take this period? Now we will change the period. Okay? Because a periodic, we only take one period. It doesn't matter which period we take. We just take one period. Okay? Yeah, just a minute. Yeah. Because when we do, yes. Yeah, we should be a little careful. Yeah, because right. Well, although it's the same, yeah. But when we do Fourier series expansion, yeah. Yeah. Right. Yeah. Yeah, it could be different, right? So when we take different period, the calculation could be different. Yeah. Yeah, all right. Yes. If that one, yeah. I try to give you, because the expansion on this interval is simplest, symmetric. If you change a non-symmetric interval, much harder. Yeah, it will be much harder. Yeah. So I will give you a symmetric interval. Yeah. Otherwise, too much calculation. Yeah, too much calculation. Yeah. All right. So, I will give you the, here. I will give you, that interval to do the calculation. Yeah. So then you can save 1/2 calculation. Yeah. So all the function. Yeah. Yeah. So, all right. Yes. Here it's even function. Yeah. I changed to odd. Yeah. It should be even function. Okay, even function. Then we only calculate A coefficients, no B coefficients. Yeah. A, we have formula. Okay, so A0, so the formula. All right. Yeah, we can, because A0 in interval from 0 to pi, you can remove absolute value. Sign non-negative between 0 and pi, you can remove absolute value. But for our homework, between 0 and pi, you cannot remove. You need to split into two sub-intervals. Yeah, so this one easier than your homework question. Okay, yeah. So then 1/2. Yeah. All right. Then AN, for sine function absolute value from 0 to pi, you can remove absolute value. Yeah. So easier than your homework question. Okay? Yeah. Then, so you need to use that, formula. Yeah. Product of two sine cosine function. Okay? Product. So there is a formula for that. Okay? Yeah, formula. Yeah. 1/4, right? Yeah. Yeah. So that's why I missed that. Yeah. Because we multiply 2 here, right? So 4th. Yeah. 4th, right? Yeah, because we need to multiply that 2 to get this formula. Yeah. Yeah, so that's why I feel there is a difference. 4th here. Okay? All right. So then, next we can calculate individual one. So next one, that one. So that's why. Yeah. So yeah, when I did calculation, I noticed there is a difference. There is a, two difference. Yeah. So here I find a problem. Yeah. I need to put a 2 there. Yeah. To get that. Yeah. All right. So then, to find this one, evaluate at a pi, evaluate at a 0. Can you do the calculation like that? How to evaluate at a 0 and evaluate at a pi? Do you know how to do that? The basic calculation? Yeah. All right. First, let's look at evaluate at a 0. Yeah. At t equals 0, we only calculate the bracket. Okay, yeah, 1/4 we can leave out. So t equals 0, 1 over m minus 1 minus m plus 1. Okay, that's 2 m minus 1 m plus 1, right? 2. Can you see that? Yeah. Yeah. Common denominator, difference, numerator 2. Difference, numerator 2. Yeah. Yeah. But at t equals pi, so let's look at the bracket, still bracket. Okay? The bracket cosine parenthesis n minus 1 pi, that is negative 1 to the n minus 1. Right? Cosine n plus 1 pi, negative 1 to the n plus 1, right? Cosine k pi, cosine k pi equals negative 1 to the k. Yeah. Cosine k pi equals negative 1 to the k. Even, odd. Even is 1, odd is negative 1. So even is 1, odd is negative 1. Okay? So that's cosine. Yeah, here. But here, n minus 1, n plus 1, are they the same? Can you see that? Negative 1 to the n minus 1 and then negative 1 to n plus 1, the same. Yeah, because the difference is 2. 2. So they have the same parity. Okay? Both even, both odd. Both 1, both negative 1, right? Same parity. The two exponent numbers have the same parity. Okay? even, odd, yeah, then the same. All right. So then my simplification is, yeah, so I hope you can see it, the simplification. 2 times negative 1 to the n minus 1. You can use minus 1 plus 1, the same. Okay? Then denominator n minus 1, n plus 1. N minus 1, n plus 1. Yeah. All right. So we evaluate. After that evaluation, now can you see, because 1/4, 2, numerator 2, 1/4, you can cancel out 2, you get a 1/2 n minus 1, n plus 1, negative 1 to n minus 1 minus 1, right? Yeah. This basic step you need to do, okay? Yeah, so pi. Oops, sorry, 1 is plus. Yeah. 1, yeah, here is plus. Is plus. Plus. Yeah. Because pi, you have this part. 0, you have this 1. Okay, the minus. Yeah, you have that. 1/4 and a 2 cancellation. Okay, 1/4 and those 2 cancellation. 1/4. So 1/2. 1/2. Okay, all right. Yeah, so after you get this one, we are ready to write the Fourier series expansion. Yeah, so here, this is my answer. Yeah. So let me erase the calculation part. So, oh yeah, so here, yeah, because in my calculation, we recover that 1/2. Yeah, so here, remember I changed, I need to add 2 here. Okay, I missed that too. Yeah. So we added this 2 back because of that too. We lost that too. So 4. Okay. All right. Then we are ready to write the Fourier series expansion, and this 2 should be 1. Yeah. Yeah. The reason is, yeah, look at this number. N is even, it's 0. Okay, so this number, even n. N even, it's 0. N is odd, sorry, N even, not 0. N even, negative 2. N is odd, 0. Okay? Yeah. Even negative 2. Negative 2, denominator 2 cancellation. So negative 1. Yeah, so that's why the numerator all 1. Yeah. So the even terms left. Okay? All the terms, when n is odd, it's 0. Yeah. Odd, because this n minus 1 becomes even. This becomes 1. 1 minus 1, 0. Okay? So all the terms all gone. Okay? All the terms all gone. So even terms left. Even terms left. Yeah. Even terms left. Okay. Yeah. Yeah. So here, yeah. So here you can see, even I give you this interval already, this kind of computation already a little hard. But the good thing is you can use Wolfram alpha to do this calculation. Okay? So it will feel very messy. Yeah. But do you know how to, for this one, Wolfram alpha entered the symbols, do you know easily? Yeah, so, some, friendly, yeah. Yeah, because there is a, icon, so you can select, right? Yeah, integral, yeah. Yeah, so you can do the calculation. Use Wolfram alpha. Yeah, yeah, but I won't make it too hard. Yeah, so this will be the hardest. Yeah, so we will treat, but this kind of calculation will be the, how far we will go. Okay, yeah, so you will see. We just go this far. Okay, yeah, because this is similar to your homework, right? Similar, different, harder.
I don't know how to do it on
Homework.
On number 7.
Oh, so you don't know how to do homework number 7?
Yeah.
Homework number 7?
Yeah.
Homework number 7. How to do it? You have no idea? Oh, yeah, let me talk about that. Oh, let's take a break. After break, let's talk about that. Okay?
Was this example on the slide? I know we were talking about switching intervals. This problem was done inside of 0 to 2 pi.
Yeah. Oh, we change. We assume. Yeah. If it's just too much harder. Yeah.
Okay, so
too much harder. Yeah.
We assume that the absolute value, we can get rid of the absolute value and just do 0 to pi because
Yes.
the negative pi part was
So-
eliminated because of the absolute value.
Symmetry, not eliminated. Yeah, by symmetry. Yeah. Because our all formula, when we choose the formula, we already consider symmetric part. We double the symmetric part. When we use the formula, we already double the symmetry. Right. We double the symmetry part. Double. Original one, there is a 2 here. So we double, it's gone. So we consider the symmetry formula already. So we already considered that. So the symmetry.
Wait, so why are we not doubling the first one?
The first one, original one, has a 2. If you look at the formula, the original one, there is a 2 here.
Oh, it's 1
So,
over 2 pi.
right, 1 over 2 pi. Then we double.
Double it.
Yeah, we double that.
Because of symmetry.
Right, the symmetry. Right.
Thank you.
Yeah.
Wait, I have a question. So, if you're just finding R of t, how is that a particular solution? Or that you
Good,
didn't
good.
finish?
Yeah, I will finish. Yeah. So let me finish the second half. Then we look at the homework. Okay? Yeah. Then, yes, the second. Oh, so you have question on the homework? Yeah. Okay. Yeah. Let me